Okay, before we do these questions, understanding saturation. So, if something is 1% vapor and 99% liquid, it's saturated, right? And as, let's take for the evaporator, as evaporator boils this liquid off, one, the temperature does not change. So it remains the same as it works its way to 99% vapor. As it makes its way to 99% vapor and 1% liquid, the temperature has not changed as it's done this. So as it's boiled off all this liquid, the temperature has remained the same. It's only once you go above saturation that it becomes superheated, or once you go below saturation that it becomes subcooled. With that said, this first question is asking, in a 410 system running with a suction pressure of 116.7 psi, the suction line temperature is 39 degrees. What is the state of the refrigerant in the suction line? First, anytime you see a pressure, it's converting to a saturated temperature. So in this case, when it says suction pressure, you'll be getting your SST. Down here it says discharge pressure. When you convert that, you're getting your SCT, your saturated condenser temperature. So, what it's asking is, what is the state of the refrigerant in the refrigerant line? Well, once we convert it, we know the SST is 39, and we know there's no temperature difference in the suction line. So, because it's the same as the saturation, the SST, you know it's a saturated liquid vapor mix. And that's what's written down here. Down here, they switch it up a bit, and it's kind of cool how they did this for me teaching. So you have a suction pressure of 110, or we'll just call it an SST of 36. The suction line temperature is 36.8. What is the state of the refrigerant in the suction line? So in order to calculate that, you're essentially calculating superheat. You are doing your SLT minus your SST, which is 36.8 minus 36 equals 0.8 degree Fahrenheit. So you know it's 8 degrees above saturation, which is superheat, and therefore you know it's 100% vapor. Because if it's superheated, it's always a clear indicator that it's vapor, 100% vapor, right? During the saturation process, the heat or the temperature stays the same, right? 39 saturated, 36, this goes 0.8 above, then you know, oh, it's 0.8 superheat. So yeah, that's how you do that. The bottom is essentially the same thing, just with the condenser. So you're running a discharge pressure of 316.9, but we'll call it an SCT of 100 because that's what it converts. So it's running with an SCT of 100 degrees, and the liquid line is 100 degrees. What is the state of the refrigerant? Well, because the liquid line is the same as the saturated condenser temp, we know saturation means liquid vapor mix. It's a saturated liquid vapor mix. Down here, same question. A discharge pressure or an SCT of 100. The system running with an SCT of 100 has a liquid line temp of 99. So to calculate subcool, you are doing SCT minus your LLT, which is 100 minus 99 equals 1 degree Fahrenheit. So we know that it's 1 degree below saturation, which means it's subcooled, and subcooled is 100% liquid. 100% liquid. Hopefully I explained that good enough. I hope that makes sense. Let me know if it doesn't.